Distances between objects and space are often so staggering that the human mind is barely able to fully appreciate them. Sometimes, even light takes thousands of years on end to travel from one object to another. However, among myriads of stellar systems scattered across the vast expanses of the universe, there is only one that may be truly called closest to us. There are 3 stars mutually bound by invisible threads of gravitation that lie comparatively nearby by space standards and naturally attract our closest attention. So, what is the Alpha Centauri system? Like the first in outer space, the Earth has been emitting structured radio signals into space for around 100 years now. The radio noise from the Earth reached dozens of other stellar systems long ago, including Arcturus, lying 37 light-years away from us, and Aldebaran, which is roughly 65 light-years away. Besides, our radio signals may be heard on the surfaces of a great number of potentially habitable exoplanets, like Cross 128b or Gliese 667c. Still, the triple stellar system of Alpha Centauri remains the closest neighbor of the Sun, which automatically makes it the first obvious candidate for the destination of the first-ever interstellar flight. Alpha Centauri is known to be a multiple stellar system made up of 3 components. 2 of the larger ones are relatively close to each other. Seen with the naked eye, they appear to be a single source of light. The 2 components follow a slightly elongated orbit around the common mass center, which takes around 80 years to complete. The maximal distance between the stars may reach 35 astronomical units, with the minimal distance reaching 11.2 astronomical units. As for the distance between these objects and the Sun, it is reportedly 4.36 light-years. The most massive, the largest, and the brightest component in the system is dubbed Alpha Centauri A. This is a main sequence star with a mass of about 108% that of the Sun. Its radius is reportedly 1.22 times that of our Sun. Even though the surface temperature and the spectral class of Alpha Centauri are close to those of our star, it emits 1.5 times as much energy. There are no confirmed exoplanets in the environs of this star. However, while the star was being observed in the infrared in 2021, some evidence was found of there being a planet-like object close by. According to preliminary estimates, its mass may be anything from 9 to 35 Earth masses, and its radius may measure 3.3 to 7 times that of our planet, 1.1 astronomical units away from its parent star. The hypothetical celestial body completes a full orbit around it within roughly a year. Additional observations are called for to verify the data, which can be done with the help of either the James Webb Telescope or else Earth-based observatories. The second component of the system is called Alpha Centauri B or Ptolemy, and it also falls into the class of main sequence stars. However, its mass is 10% less than that of the Sun, and its radius measures only 86% or so. That of the Sun Ptolemy is also slightly cooler than our star. Its surface temperature is reportedly 5260 Kelvin, or slightly lower than 5,000 degrees Celsius. With these factors combined, the celestial object has an orange hue, and its luminosity is on average twice as low as that of our Sun. Incidentally, Alpha Centauri E emits a lot more energy in the X-ray range compared with other objects of its class. Besides, the star is peculiar for its temper, and there are bright flares and ejections to be seen on its surface. No confirmed exoplanets have been detected near this star. Either in 2012, a group of astronomers from the Geneva Observatory put forward a suggestion that there was a planet very close to it, whose orbital period was around 12 days, and whose radius measured slightly less than that of the Earth. The suggestion was made based on 4 years of observation of the star's proper motion. However, 3 years later, a mathematical error was detected to have been made in the course of data processing, and so the idea of there being a planet was found to be erroneous. The third component of the system is a stark contrast to the first 2. It is a red dwarf with a mass approximately 12% that of the Sun. Its size is about 7 times smaller than that of the Sun. Its surface temperature is only slightly higher than 3000 Kelvin, and its luminosity is just a measly 0.17% that of the Sun. Of all the components of the Alpha Centauri system, it is this dim space object that is the closest one to the Sun, lying 4.25 light-years away from it. This is what earned it its name, Proxima Centauri, which is Latin for closest. Besides, the object is getting nearer and nearer. Thus, in 26,700 years, it will be only a bit more than 3 light-years away. Still, this star cannot be seen from the Earth on account of its slow luminosity. Proxima is noticeably far from its two companions in the stellar system. This distance is currently around 13,000 astronomical units, or 0.21 light-years. But in the next 300,000 years, it is expected to gradually shrink to just 4,100 astronomical units. It takes Proxima 547,000 years to orbit around the system's common mass center. Unlike its two larger neighbors, the Proxima Centauri system boasts 2 confirmed exoplanets, as well as at least 1 hypothetical object. Besides, studies of the star in the infrared allowed scientists to assume that there is a dust string and probably a great number of small celestial objects, like asteroids or comets. The first planet in the system, Proxima Centauri B, was detected in 2016 by the radial velocities method. 4 years later, in 2020, it was confirmed by spectrographic studies with the help of the largest Earth-based telescope on our planet, VLT, the Very Large Telescope. According to the updates, the exoplanet lies 0.05 astronomical units away from its parent star, and it takes it roughly 11 Earth days to complete a full orbit. Estimates show that the planet's mass is 10 to 20% bigger than that of the Earth, and its radius measures about 1.3 times that of our planet. Mathematical modeling revealed that Proxima Centauri B gets about 1.5 times as little thermal energy from its star as does the Earth from the Sun. Its average temperature is 234 Kelvin, or 39 degrees Celsius, below zero, which means that hypothetically there could be liquid water in some areas on the planet, as the celestial body is extremely close to its host star. However, it is likely to be tidally locked, so it faces the star with one on the same side. A dense atmosphere could compensate for sharp contrasts in temperatures, which are inevitable in such conditions. But just like any other red dwarfs, Proxima Centauri is often seen to eject stellar matter. Also, ionizing radiation flares are observed. It is assumed that such activity gradually destroys the atmosphere of the closest objects. A powerful magnetic field that could be encompassing Proxima Centauri B could offer some protection against the destructive process. But chances that there is any magnetic field there are thin in the year 2020. Another planet was confirmed to exist in the system, a space object dubbed Proxima Centauri E lies roughly 1.5 astronomical units away from the center of the system. Its orbital cycle is slightly over 5 years, but the 40 trillion kilometers of space vacuum between us are too overwhelming for us to cover. At this point, it takes light over 4 years to get there. But for humans, such speeds are still in the realm of fancy. Even today's swiftest state-of-the-art spacecraft would need tens of thousands of years to cover this distance. However, application of advanced technologies could theoretically greatly reduce travel time. Since the very dawn of space exploration projects, of a great number of spacecraft have been suggested that hypothetically would have been able to negotiate interstellar distances. Nevertheless, not a single one of them has been actually designed. Most of these would-be missions were forgotten, but one is still under active consideration. This is the Breakthrough Starshot program, which implies sending as many as 1,000 microprobes to Proxima Centauri. As soon as in the first half of this century, they will not measure over 1 centimeter in size, and special thin and durable sails are planned to be created to aid the probes. Along the sails will be blown out, as it were, by impulses of a highly powerful Earth-based laser estimates show that an interstellar probe like that is going to be leaving the solar system at a speed roughly 20%, that of the speed of light. With the overall travel time around 20 years after that, it will take another 5 years or so for the data collected by the mission to reach the Earth. Remote stars may currently be out of bounds, but we can observe them apart from James Webb, which is already transmitting data to the Earth from its orbit. The launch of another orbital telescope. Ptolemy is scheduled as soon as in 2023. Even though this space complex is not as advanced as James Webb, in terms of its technical characteristics, it has its edge in its studies. Ptolemy will be targeting specifically Alpha Centauri and its nearest stars. In spite of all difficulties, the secrets of the universe are slowly giving way to our tenacity, and everyday space is getting closer.